Hello, welcome back to another episode of Codercise. In today's episode, we're going to be using some third-party Deno modules to pull in data from the internet, hash some passwords, and verify that they match. All the passwords that we're using are from randomuser.me, and the modules we'll be using are from the Deno land third-party module directory. I'll be including links to all of them. We'll also be sharing this repository up on GitHub. So if you're into these videos, you're liking them, make sure to follow me on Twitter at twitter.com/hados585, on Twitch at twitch.tv/Codercise, and on YouTube, where you're probably watching this video right now. Let's get into it. So here we are, we're on the randomuser.me website. This website's pretty useful. It will give you a random user with some very random information here. It includes a little bit of documentation on making a jQuery AJAX request, and then these are the kind of results you can expect back from it. Every time we refresh this page, we're going to be getting a new user with new information. The one we care about today is this password. They have an API that you can use, and this is the link just here. So I'm going to paste this into the browser, which just gives us this JSON results here. You also got the ability to include a seed parameter, which I've done in this tab here. So we can include the seed Codercise, and every time we refresh this page, we are going to get the same result, which will be useful for our tests here. The libraries we're going to be using is the Bcrypt library, SHA-1, and SHA-256. All of these are available on the Deno third-party modules directory, and you'll be able to find them by name there, and I'll include links in the description on this video. I've got a new file here called password-checker.ts, and this is where we'll be working today. So first of all, let's start creating our files. So we're going to first write some code that will be pulling down our user from the randomuser.me website. So it's going to be an async function, and we'll just call it getUser for now, okay? We'll have a variable called user.json. Should be a capital there. JSON, there we go. So we'll be waiting and fetching. And now the URL we need is this one we had over here with our seed in it. Okay. Come back, so put this in here. All right, so we can assign our user variable is going to be await user.json.json. Okay, so this is just going to make a request to this URL and grab the JSON out of it. And we can just log this data here to make sure that it is doing what we expect. Oops. Don't want that in quotes, so I want to be showing the variable. Yeah, so open up my terminal. We're going to say Deno, oops, that's not how you spell Deno, run. We're going to allow net. And what's our file called? Passwordchecker.ts. Great, so that ran, but that did not log anything. And the reason is because I am a fool and did not call my function. There we go, happens to the best of us. Great, so here we can see, what a fun error. We can see our results here from that request. And if I run this again, because we are using this Codercise seed, we're gonna get the same result. So you can see Ella is coming back every time. Great. So next, we'll be starting with Bcrypt. If we look at the data we're getting back from randomuser.me, there is no sort of Bcrypt value here. So we will just be hashing it using Bcrypt and then just doing a quick match there. And that'll be more of a demo of sort of how the library works. So we're going to do this in a new function called Bcrypt. call it Bcrypt check. So here we will be, first we should be passing in our user, and we'll actually just grab the login data, which is all we really care about here. So login data, will be a new value. It'll be based on user results, the first result, and then login, which we're just going to be grabbing this block here. So let's check that that worked. We'll just call it again. Maybe we'll just use the password. So we're going to be getting, oops, just sort of confused myself a little bit here. We'll first just login data. And while this is a TypeScript file, I'm not going to worry too much about types in this case, just because I don't want to get too deep into that. So now that I've thoroughly confused myself, I'm going to be just commenting out that, because I'm trying to do two things at once, which isn't working for me. So run the password checker. Great. So we've just got this login data, and that's what we'll be working with for this video. So we have the password itself. We have the salt. We have an MD5 value, SHA-1 value, and SHA-256 value. All of these are their own hashing algorithms. It's definitely its own study. I will not be going into how these work, but they are pretty interesting. That is definitely, could be a whole series of videos on its own. So for now, I'm actually just going to do this all in the same function just to keep it easy and give up on that endeavor. And we're going to need our Bcrypt library first off. So let's hop over back to here. To import it, they've got in the README here. We can import it this way. So I'm just going to have that up at the front. So we're going to import everything from this library, and we're going to be calling it Bcrypt. So next will be, we can follow their docs here. So you can see they've got a little test hash here. You can check a password doing this, and you can also generate salts for your passwords. So let's get into it. We're going to go BC, which will be for Bcrypt. And we're doing an await. It's going to be bcrypt.hash. We'll be going login data.password plus login data.salt. Okay, and if we do a console.log BC, let's put that in quotes again. Okay, so now we'll be able to see what the password looks like when it is run using Bcrypt. The reason this happened is I forgot something out of the library. You need to run it with the unstable flag. It mentions that here if we are going to be using await when we're hashing our passwords. So let's try that again using the unstable flag. And this is really like a benefit of Deno, is we're explicitly allowing all of these things. I'm actually not sure that we need allow net. Oops, yes, we did. Of course we did, because we are calling out to the internet. Great. So here we can see our bcrypted password. And we can just do a simple check to see if our password is matching. And I'm just going to go here. We'll call this one BC match. Again, we'll be awaiting bcrypt.compare. It's going to be login data.password. Whoops. password plus login data salt. And we'll be comparing that to BC, which is the original value of our hash up here. We can console.log does Bcrypt match, and we'll be saying BC match in here. Great. So we should be seeing that these two passwords will match. Great. So that you can see that these passwords here do match. Now that's not very exciting. We know we just hashed it, so of course it should be a match. But what will be a bit cooler is when we start using SHA-1 now, we should be able to see that someone else has hashed this password, which means we don't know kind of what's in it, but we can use the same algorithm to check and to make sure that the password we're receiving from the user matches what they've submitted in the past. So I'm just going to add a console log here, which will say SHA-1. And we'll chuck a couple of new lines around it. Should just be one on that side. We're going to be importing the SHA-1 library, which is here. This one, we don't import everything from the library. We're importing just the SHA-1 part of it. Great. So here, again, have a read of the docs on how it works. So we'll be saying SHA-1, const SHA equals SHA-1. We'll be doing login data dot password and the login data dot salt again. Here we'll be taking in so this is the value of the input encoding and then also the output as well. So we've got, here we can see input encoding, output encoding. So our input is UTF-8, our output will be hex. Coming down here, now we're going to say SHA-1. Sorry, SHA to string. Let's shuffle that there. Great. And then we can also do our check here. So we're going to say does SHA-1 value match? Again, so we'll be doing SHA triple equals login data dot SHA-1. Okay, so let's have a look at this guy. Running this one again. Here's our login data. Here is our bcrypted password. Our bcrypt values match. And then SHA-1, here is our SHA-1 value. And then the SHA-1 value does match that value provided from randomuser.me. So that's pretty cool. We've gotten a value from somewhere else. This has been run through this algorithm, including a password and a salt. And then we've been able to run that same algorithm here, which has given us the same result. So we can verify that the user providing us this password knows what that value was before. And now lastly, let's do SHA-256. So we'll say, I'm going to call this one SHA-2. We're going to need to import this library, which is over here. Again, shout out to Chief Biko, who made the SHA-1 and SHA-2 libraries, and then James Broadberry, who did the Deno Bcrypt library. Again, links to those will be in the description link of this video where you are watching it right now. So we're going to include this up here, SHA-1. Now we've got SHA-256. Just a note on SHA-1, you shouldn't be using it for your passwords anymore. Please do stick with SHA-256 or SHA-512 or another library that kind of handles password encryption for you. This format of encrypting passwords is very standard and is, if you're a new developer, it's worth reading up on how this is done, why it's done, and why you shouldn't be storing plain text passwords in your database. So here this SHA-256 function is going to operate very similar to the SHA-1 function. We're going to be including the password and the salt again. Our input format is UTF-8 and our output is hex. So we'll include just a little title card again, which will be SHA-256. I didn't like that formatting before, so I'm going to get rid of that new line. We'll be showing the SHA-256 value, so it's SHA-2 to string. And then we'll be checking if it matches. So does SHA-256 value match? And then SHA-2 equals login data dot SHA-256. Great. So we're going to run this now, and hopefully we get the same results. Oops, what have I missed here? I found this before. So these docs include, or the README at least includes a fixed value here. And what we actually want is to change that. I think this is going to be 02. Yeah, so it's a little bit annoying that the docs give you code that instantly hits an error. What I did when I first encountered this is I first just removed the version at all in the URL, but also explicitly including the current version, which is 102. You've got 100, 101, and 102. So hopefully they'll update that shortly. So here we go. We've got Bcrypt. You can see our workers fire up. That's just kind of how the Bcrypt library runs. It's using web workers for its processes. So we can see our Bcrypt value. It does match. We've got our SHA-1 value here, which matches to the SHA value provided by random user. And then we've got SHA-256 here. So this is a longer, more secure hashing algorithm. And then we can see that that SHA-256 value does match the value provided by randomuser.me. So I hope you've enjoyed this video. It's been a bit shorter than my usual videos. What we've done is we've pulled down a few third-party libraries from the Deno land third-party module directory. We've then pulled a fetch request, pulling down API data from randomuser.me. And then lastly is comparing these values and making sure that that our crypto library is working with the randomuser.me provided data. Hope you've enjoyed this quick little video on Deno. If you're playing around with this, you're experiencing some different cool use cases, let me know in the comments, let me know on GitHub as well. The GitHub repository for this project will be online shortly. You can all find me on Twitter at twitter.com/hados585. You can find me on Twitch at twitch.tv/Codercise. And you can find me on YouTube, where you're probably watching this video right now. Codercise there as well. Hope you've enjoyed it. If you've got any comments, suggestions, or things you'd like to see, let me know in the comments below. And I look forward to seeing you next time. Bye.